Okay, today we're going to be looking at scale factor. And what scale factor is, it's like when you're enlarging a photograph or maybe reducing an image, it's how much bigger or smaller is it getting? By what factor is it increasing or decreasing? So pay close attention because there's a couple of different kinds of scale factor we're going to talk about. So the first one we'll look at, and I'm going to use the abbreviation SF for scale factor, is we're going to look at this one. This is our original image over here. It's a square. Here's a bigger square. Okay, so we basically went from this one to this one. And the question becomes, by what scale factor did it increase? So when we're looking at that, as I'm going to change my colors here to make it a little easier to see, we went from 3 to 6. Well, how much did that increase? Well, it's 2 times bigger. So our scale factor, if we look at it, we just do the new image, which was 6, divided by the original, and we get a scale factor of 2, which basically means the length of this side is 2 times greater when you look at the new image. Now here's a question. What becomes when we talk about scale factor as it relates to area? Now area is simply length times width. So we're going to take a second and look at that. Okay, what's the area of this rectangle? Well, it's 3 times 3 or 9 square units. What's the area of this one? Well, it's 36 square units. So when we're looking at scale factor as it relates to area, we still put the original or the new area on top and the original area in the denominator. So notice that if we're talking about area, it's 4 times greater. If we're talking about the side length, it's 2 times greater. So this is about side length, and that's what we usually use. This is about area. So let's try that on another problem. Okay, so let's look at comparing the scale factor of these two things. So we got to look at the sides. Here is 5. What is in the corresponding side on this one? Well, 15 is in the corresponding place. We have to look at that. You don't want to mix like 5 with 6 there. They have to be in the same place because these are similar figures. So to do scale factor, I'm going to put my SF. If this is the original image, this would be the new image. So I would do 15 over 5, and that equals 3. So the length of this side is 3 times greater than the original. The length of this side, which is 6, is 3 times greater than 2. So now let's talk about area. When you talk about scale factor with area, it's slightly different. Okay, so we're going to see if we can't figure this out. And sorry about my handwriting, but hey, I'm writing with a cursor. Okay, so here we go. The area of this one is 10. Well, what's the area of this one? Well, 6 times 15 is 90. So let's compare those two areas. We would have 90 over 10, because 10 is the original, and we would get a scale factor of 9 when we're talking about the area. So basically, if we're talking about the length, it's just 3. But the area increases by 9, which just happens to be 3 squared. Interesting. Now let's look at one last different little case. This time this is the original, and this is the new image. Notice what happens if we go ahead and we put our new image scale factor in the numerator, which is, let's just pick side 2 here. Well, what's in the same place as the 2? It's the 4. So in this case, we get a scale factor of 1 over 2. Anytime you have a fraction for a scale factor, that means the image is getting reduced or is getting smaller. Now let's compare their areas. Let's do the scale factor for area. Now this is going to be slightly different. And the best way to do these is just to work them out, not to try to do anything fancy. So the area of the original is 40. The new one is 10. So we put the 10 in the numerator because that's where the new one goes, and the original in the denominator. Well, when we simplify that, the new figure has an area that's 1/4 of the original. There's some interesting mathematical things going on there. See if you can see it.